All right, on to lesson 5. So we're going to solve and graph inequalities. So if you're watching this video, you should be following along, taking notes on pages 18 and 19 in your workbook. Be tracking on your checklist. We're going to start with number 1, which is on page 18. And so we're switching to solving inequalities now instead of equations. And they're very, very similar. There is one major rule. So there's lots to write in this video. Make sure you're pausing the video and writing everything in your workbook. Anything that I write on the screen, you should be writing in your workbook. So the first most important rule, our only new rule, is if you multiply or divide by a negative, you have to flip the sign. So our signs we're going to be using is less than. So I wrote it up here at the top, less than and greater than. Remember, the mouth of the sign always opens towards the bigger number. So if you pretend it's like the mouth of an alligator, it's always going to eat the bigger number. So why is this our rule? I'm going to do an example. So back to the blue area, I wrote example is 2 less than 3, right? That's true. 2 is less than 3. If I look at the bottom of the screen, I have a number line. 2 is further to the left than 3. So the further to the right I get, the bigger the numbers get. If I multiply both sides of that by a negative, like my rule says, so maybe I'm going to multiply by -1 and multiply by -1, I would have -2 is less than -3. And that is not true. See, now when I multiply or divide by a negative, everything switches signs and now it's negative. That's not true. Because looking back at the number line, right, as soon as I hit 0 and I go into the negatives, now all the numbers are in reverse order. So actually, the bigger the number, the lower the value. Everything going to the left is actually smaller. So because of that, whenever I multiply or divide both sides by a negative, I have to switch the sign. So all I have to do is switch it from being less than to greater than. So we're going to do the same thing when we're solving today. That's my number 1 rule. And that's only because the numbers switch order when I get to the negatives. So you see, my question says solve each inequality and graph. There's A and there's B. You guys are actually going to do B on your own. We're going to do multiple together, but you're doing B. So B, your final answer should be X is less than 1.75. So try that one on your own. That should be your final answer. So see if that's what you get. And if not, maybe ask for help. But for A, we're going to set it up just like I would set up an equation. I'm going to do a long line down through the inequality sign. And I'm going to get to solving. Same steps, doing everything to both sides, opposite operations. I see the parentheses, so I'm going to distribute the -3 to both terms inside the parentheses. -3 times 2x is -6x. -3 times 2 is -6. And that's less than still 10. Now I'm going to get rid of that -6 with a +6, opposite. Do it to both sides. Cancels out the -6. Great. -6 times x is less than 10 plus 6, which is 16. Divide by -6 to get x. X is less than. Now that's my golden rule. I have to switch the sign, right? And that's how it goes. Be always checking yourself. I divided by a negative. If you multiply or divide by a negative, flip the sign. So now I just switched it from being less than to greater than. That's all I got to do. So just always be checking yourself for that. So my -6 is canceled out. I could write my answer as a fraction. I could keep 16 divided by 6. Maybe I could simplify. I'll put it in the calculator for this one. I'll get -2.6 repeating. 2.66666. Just because we have a lot of other steps to focus on than the calculating. So that's my final answer. It says to graph it, so I want to put it on a number line. So a long line, arrows on both sides to show it keeps going. And so maybe I don't always have to put 0 right in the middle. Maybe I'll do like -2 in the middle because that's where my solution starts, -2.6. And so when it's greater than or less than, I'm going to start with an open circle. So negative 2.6 would be in between negative 2 and negative 3, slightly closer to negative 3. So an open circle, because it's greater than and not equal to. And then x is everything bigger than that. So I'm going to shade in everything greater than negative 2.6. Shade it or darken it or use a different color, however you want to show that. A different color would be perfect. Open circle, x is greater. You try that same thing for b. See if you get x is less than 1.75, and then try to put that on a number line. Be pausing as we go. I'm going to go quickly, but you need to take your time and write down everything we write. So here's another example, number 2, solving with variables on both sides. And so here I had some extra note space for you to write down a reminder of those open circles and closed circles. So in the notes, if x is less than or greater than, that's when it's an open circle, because it's not equal to that number, only greater than or less than. Then when it's less than or equal to, or x is greater than or equal to, that's when we do the closed circle. That means it's everything greater or less and also including that number. So we shade it in. Here we have a new example. It's also still less than, so we're still doing open circle, but I just wanted to mention that. If I have x on both sides, I want to first eliminate one of those x's. So I have 2x and I have 5x. I want to isolate just one x. So I can just eliminate one of them. I can subtract the whole term away. Maybe I'll do the smaller one. Then I might not have to deal with a negative. So I'll subtract 2x. When I subtract 2x on the right, I have to take it from the 5x. I can't take it from the 22. We can only combine like terms that have the same variable. But 2x minus 2x is 0. And then I'll have 0 minus 5, negative 5, is less than 5x minus 2x, which is 3x. So I only take away x's from x's and constants from constants. It's like apples and oranges. So make sure you're paying attention to what you're combining like terms with. And so now again, I'm just going to try to get x by itself on the right. So I'm going to get rid of this minus 22 with a plus 22. Do that on the left as well. They cancel out. Negative 5 plus 22 is positive 17. That's the same as 22 minus 5 is less than 3x. So 3 times x, the opposite of multiply by 3, divide by 3. So I do it to both sides to get rid of that 3. And then 17 divided by 3 is 5.6666 repeating. I hope that's right. Yeah. And then that's less than 1x. So that should be my final answer. X is greater than 5.6 repeating, or 5.6 repeating is less than x. I can read it either way. And so when I put that on a number line, again, maybe I'm not going to put 0 in the middle. Maybe I'll do 5 and 6, 7, 8, right? And on the other side, 4, 3. That almost looks like a negative. Okay. And so my answer is 5.6 repeating. So in between 5 and 6, open circle because it's not equal to, only less than. And so x is everything greater than that. Everything to the right, everything bigger. And so I'm shading it in. It doesn't have to be perfect. Just make sure we can tell which side of the circle you're shading. X is greater than 5.6 repeating. Perfect. Last examples. If I have infinite solutions or no solutions. This is a little bit different than equations. If it's something, a statement that's always true, it has infinite solutions because it's true for every value of x. If it's something that can't be true, it'll have no solutions. So again, lots of practice here with the parentheses. I see the parentheses, so I'm going to set my equation up, and I'm going to distribute. Negative 2 times 4x is negative 8x. Negative times a negative is a positive, so plus x. And so I should have negative 8x plus 4. is less than negative 8x plus 4. And so that's an identity, right? We have the same thing on both sides. And so usually with equations, that would mean it's always true. But in this case, they're saying that the same thing is less than itself, which actually doesn't make sense in this situation, right? That's like saying, a different example would be like 4 is less than 4. That can't be true. So actually now when we have the same thing on both sides, that is never true. No solutions, never true. Right? That's my answer, no solutions, because that's never true. So that's almost backwards compared to equations. Similar now to B. For B, again, setting up to solve and distributing the negative 3, I'll get negative 6x minus 3 is greater than negative 6x minus 5. So when I go to eliminate one of those x's, say I'm going to add 6x to try and get rid of one of my x's, what happens is odd, because then since the x's are the same on both sides, they actually both eliminate. Now I have no x's on either side, and I just have 0 minus 5, negative 5, less than negative 3. So maybe first you want to check that. Is that true? If that's always true, then infinite solutions. If that's not a true statement, no solutions. I don't remember. Is negative 5 less than negative 3? Maybe you have to put it on a number line. And I'll see, yes, that's true, right? Negative 5 is smaller than negative 3. It's further to the left. Maybe keep going back to where you drew that first number line. Yes, always true. Yes, always true. So that means that it's infinite solutions. Infinite. And so if I want to graph that, I guess I could just do shade everything. Everything is an answer. Anything will work. It always makes a true statement. So a little flip-flopped. That one might be tricky, but not too different. So make sure you took the time to write down those notes. Take your time. And move on when you're ready.